Welcome to Lesson 25, which roughly covers pages 154 to 157 of the Automate the Boring Stuff with Python textbook. The pipe character that we went over in last lesson lets you match one of many possible groups in a regular expression, but you may also want to match a certain number of repetitions of the group. You may want to match at least one or more appearances of the group, or you may want to match the group if it appears more than 7 times but less than 10 times. In this lesson, you'll learn the regular expression syntax for matching a specific number of repetitions. So to start off with, I'm just going to import the RE regular expressions module, and let's begin with the first character, the question mark character. This says match the preceding group 0 or 1 times. It's an optional group. It can either appear once or not appear at all. So let's use some code. I'm going to use a Batman regular expression that I'll save in this Regex variable. So I'll call compile, so that'll return a regular expression object. And the pattern I want this to match will either be Batman or Batwoman. But in this case, I could just make this a bit shorter by just saying, adding a WO group and then a question mark after it. So this question mark says this group right here can appear in the text 0 or 1 times in order to match this pattern. So if we call this regular expression object's search method and search a string like the adventures of Batman, we can see that this regular expression does indeed match this part of the string. It found this pattern in this string. And we can see it matched Batman, but this will also match the adventures of Batwoman, because the WO group here can appear 1 or 0 times. It appears 0 times here, and it appears once here. But if we had something like the adventures of Woman, that actually doesn't match the pattern at all, because it can only appear 0 or 1 time, so the search method will return none to the MO variable. Using the earlier phone number example, we can make a regular expression that looks for phone numbers that do or do not have an area code. That is, we can make the area code optional. So let's enter this into the interactive shell. I'm going to create a regular expression object by calling compile and store it in phone regex. And the pattern for phone numbers, we can use that /d, which stands for any numeric digit. So we can have 3 digits for the area code, 3 digits for the first part of the phone number, and then the last 4 digits of the phone number. So this is the phone number regex that requires a phone number to have an area code. So if I had a string, my phone number is 415 555 1234, call me tomorrow. We'll just save that in the variable MO because it'll return a match object. We can see that this actually found the phone number with the area code, except this pattern, which requires the area code, won't be able to match anything if this string doesn't have the area code. So search returns none, so the MO variable will contain the none value. So instead, let's create a phone regular expression object that puts this area code into a group, and then we have the question mark to say this preceding group is optional. It can appear once or it can appear 0 times. And then in this case, we can see that the search method does return a match object for this phone number, and also returns a match object for this phone number when it doesn't have an area code in front of it. And if you ever have to actually literally match a question mark as part of your pattern, you can escape the question mark with a backslash in front of it. The asterisk character is usually called the star character in the context of regular expressions, and it means match 0 or more times. So let's go back to that Batman regular expression example. Creating that regular expression, And before we had the question mark here, which meant that this WO could appear 1 or 0 times. If we change that to a star, this means this can appear 0 or more times. So basically any number of times. This will actually match the Adventures of Batman string. It'll also match the Adventures of Batwoman string. And since it can accept any number of this WO group, because the star means 0 or more, we could say have several of that, and it would still match that string. And if you need to match a literal star that appears as part of the pattern, you can escape it with a backslash. So while the star character means match 0 or more, the plus character means match 1 or more. So unlike the star, which doesn't require its group to appear in the match string, the group preceding a plus must appear at least once. It's not optional. So let's create another Batman regular expression object by calling compile. And let's say that that WO group is now required to appear 1 or more times. This means that matching the Adventures of Batman string, it won't actually find that. This string returns, or this function call will return none. However, the Adventures of Batwoman will match it, because this WO group here appears once, and then also in this example with Woman, that'll also match, because that WO group can appear 1 or more times. And if you have to match a literal plus sign that appears in your pattern, you can escape it with a backslash. So let's have a quick example with that escaping. Let's say I'm just going to create a regex object by calling compile, and the pattern that I'm looking for is a literal plus sign followed by a literal star or asterisk followed by a literal question mark. That would match a string that looks something like I learned about plus star question mark regex syntax. And those would actually match these characters. So if you literally want to match these characters that otherwise have a special meaning for regular expression strings, then you can just precede them with a backslash to escape them. In fact, we could even have something like putting this inside of a group and saying this has to appear 1 or more times by having a plus sign that means, 1 or more times. And that would match a string that looks like this. So here, it means literally I want you to find a plus sign that appears in the string that I'm looking for. That's part of the text pattern. And this is more of a regular expression instruction saying match 1 or more of this preceding group in the parentheses here. So as a quick recap, the question mark means 0 or 1, the star means 0 or more, and the plus sign means 1 or more. But let's say if you wanted to match a specific number of repetitions of a group. We can do that in Python. I'm going to create a regular expression object that matches the string ha exactly 3 times, and we can do that with curly braces with the number 3 in between them. So if we call the search method here, we can search for, he said ha ha ha. We can see that this string is matched in the regular expression. This is kind of a simple example. You might think, well, couldn't we just have something like ha ha ha, and this would work too. This would do the exact same thing as this. But the nice part about this syntax is that you could have something like, say, if we wanted to match multiple phone numbers that either had or did not have the area code in front. So that expression would look like this, where we have the optional area code. These are 3 digits and a dash, which can appear 0 or 1 times. And then we have the rest of the 7 digits of the phone number, and then we could put all of that inside of a group, and then just say we want this phone number, we want to match 3 phone numbers in a row. Now that might look a little bit strange. Let's say they're also, they have a comma that they're separated by, except that comma is also optional. So we could put that inside of a group, and then say that comma is optional. So then this phone number regex would match a string like, my numbers are 415, 555, 1234, 555, 4242, and 212, 555, 0000. A really complicated looking pattern like this could be matched by this regular expression, where we're looking for 3 phone numbers in a row, which may or may not have the area code, and may or may not have a comma following it that separates them. And remember, this pattern would match exactly 3 of this complicated pattern. Just like we could have passed a string that has 3 ha's literally typed out, instead of using this curly brace syntax, we could have just gotten rid of this and instead copied and pasted this entire regular expression 3 times. But then at this point, it's getting kind of hard to read what exactly we mean from this regular expression. We'd have to spend a lot of time kind of piecing together what this means. So the curly brace syntax really helps out on that front. Now let's say you wanted to match, instead of 3, you wanted to match a range of possible repetitions. So anywhere between 3 and 5, you can just add a comma and then a second number. So then this becomes a minimum and maximum number of repetitions. So we could have a string like, he said ha ha ha, and that would match. We could also have 4 or 5 of these ha's as well, and that would match. If we had any more, well, this would still match, but it would only match these first 5 ha 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 ha's. And just like with slices, if you leave off this first number or second number, in this case, this is the same thing as saying 0 to 5. Or if you had 3 and then a comma followed by no number, this is the same as saying 3 or more. So there's an unbounded maximum. You can have any number of these as long as it's at least 3. So let's do a little experiment here. I'm going to create a regular expression that matches anywhere between 3 and 5 digits. So that /d was the regular expression syntax, meaning any numeric digits. Let's say I want to match a string that had between 3 and 5 of them. So I was going to call it and have it search the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. You can see that what it matched right here was the first 5 digits. I mean, it would technically match these 5 digits, but Python's regular expressions start as soon as possible, as the earliest match they can find is the match that they'll return. And also notice, it could have matched these first 3 characters or the first 4 characters. But instead, it matched the first 5 characters, and that's because by default, regular expressions in Python do greedy matches. This means that it tries to match the longest possible string that matches this pattern. So in an ambiguous situation like this string, where it could match any 3, 4, or 5 digits, regular expressions are going to match the maximum longest possible string. Now, if you want it to do a non-greedy match, you can specify a question mark after that curly brace. So this question mark is different from the question mark that means 0 or 1. When it comes after a pattern like this, as opposed to directly after a group, this means basically do a non-greedy match. So let's create this regular expression and then search that same 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 string. You can see this time it matched the smallest possible string. And this is a pattern that happens a lot in regular expression syntax. If you add a question mark, it'll do a non-greedy match, whereas without it, it'll just do a normal greedy match where it tries to match the longest possible string. To recap, the question mark matches a group 0 or 1 times, the star matches a group 0 or more times, the plus matches a group 1 or more times, and the curly braces can match a specific number of times. And if you put two numbers separated by a comma in between the curly braces, you can have a minimum and maximum number of times. You can also leave out the first or second number inside the curly braces so that you can say that there is no minimum or no maximum. Greedy matching matches the longest string possible, while non-greedy matching matches the shortest string possible. And putting a question mark after the curly braces makes it do a non-greedy match. By default, regular expression syntax does a greedy match.